Two commercial aircraft came within 300 feet of each other at Brazil's busiest airport, and it could have been prevented. It happened in seconds. At São Paulo's Congonhas Airport, Brazil's busiest hub, two large aircraft nearly became a tragedy. A GOL Boeing 737-800 was landing when something went wrong, spacing, runway conditions, or both. The tower issued an immediate abort. But on the same runway, an Azul Embraer E195-E2 was already accelerating for takeoff. Air traffic control ordered the Azul crew to stop. They didn't. The two aircraft passed within 300 feet of each other, close enough that a minor deviation would have meant impact. One crew missed, ignored, or didn't hear a critical command. That gap between instruction and action nearly cost hundreds of lives. Let's walk through exactly what happened on that runway. The GOL Boeing 737-800 was on final approach to Congonhas when the tower made a critical decision: the landing had to be aborted. The reasons varied in early reports. Some cited deteriorating runway conditions, others pointed to spacing issues with another aircraft. Whatever the trigger, the tower issued the abort command to GOL, and that crew complied immediately, climbing away from the runway. But here's where the system fractured. At almost the identical moment, the Azul Embraer E195-E2 was already rolling down that same runway, beginning its takeoff. The tower, now aware that GOL was no longer landing, issued an immediate abort command to Azul as well. Stop the takeoff. Get off the runway. The problem: the Azul crew never acknowledged it. They never responded to say they heard it or understood it. Instead, they continued their takeoff roll while GOL was climbing directly into their flight path. Within seconds, the two aircraft were separated by just 300 feet vertically, a distance that, at those speeds and altitudes, represents a razor-thin margin between a successful separation and a catastrophic collision. The Azul E195-E2 continued climbing while GOL descended back toward the airport, and by pure chance, the geometry worked. But it shouldn't have come down to chance at all. So how did an experienced crew miss a direct order to stop? The answer lies in the reality of high-density airport operations. Congonhas is São Paulo's busiest airport, handling over 100 flights daily in an environment where every minute counts. When the GOL aircraft aborted its landing, the tower issued an immediate instruction to Azul: do not take off. But that message never registered in the cockpit. Initial investigation points to several converging factors. First, radio congestion. With dozens of aircraft on frequency simultaneously, critical transmissions can be buried under chatter. The abort command may have been broadcast, but lost in the noise. Second, workload saturation. The Azul crew was deep in their takeoff sequence, running through checklists, monitoring systems, coordinating with ground control. Adding a sudden abort instruction creates cognitive overload, especially if timing is poor. Third, potential miscommunication. Did the tower use clear, standardized phraseology? Did the crew have positive acknowledgement? These details matter enormously. Even the most diligent pilots operate within human limits. When you're managing multiple systems, tracking runway traffic, and processing incoming radio calls, a single transmission can slip past unheard or misinterpreted. This wasn't negligence, it was a system failing under pressure, revealing how fragile communication becomes when everything happens at once. Congonhas is one of Brazil's most congested airports, operating with only two runways that are frequently used simultaneously to maximize capacity. This dual-use approach works fine during normal operations, but it creates a hidden vulnerability. When one operation is interrupted, the coordination between landing and takeoff sequencing can break down in seconds. When the GOL 737 aborted its landing, the tower had to immediately communicate this change not just to that aircraft, but to any plane already committed to takeoff on the same runway. At Congonhas, this handoff isn't always instantaneous. The Azul crew was already executing their takeoff checklist, focused on acceleration procedures, while the tower was managing a suddenly complicated runway situation with two aircraft in conflicting trajectories. The systemic gap here isn't just human error, it's that high-traffic airports often lack redundant confirmation systems for abort commands. Many facilities rely on a single radio instruction, hoping the crew hears it clearly over background chatter and cockpit noise. There's no automatic trigger, no secondary alert, no mandatory visual confirmation from ground personnel. When runways are shared between landing and takeoff traffic, one miscommunication cascades instantly into a near collision. What saved these 400 people wasn't skill or luck, it was the collision avoidance system that screamed a warning just in time. But that shouldn't be our only line of defense. Mandatory readback protocols, staggered runway scheduling, and redundant visual confirmation exist for exactly this reason. Aviation safety isn't about perfect crews, it's about systems designed to catch human error before metal meets metal.